Hi kids, welcome to Lucky Maths. Lesson number 19, your grade 11 book, Matrices. 19.1, Introducing Matrices. Here you have a simple example that you can identify matrices. Have a look. This table shows your marks obtained by 3 students for a test. Students are Vimal, Farooq and Radha. Subjects are mathematics and science. Vimal got 75 and 66 for maths and science. Farooq got 72 and 70 for maths and science. Radha got 63 and 81 for maths and science. Suppose you are asked to write this information in matrix form, we can write it as within a long bracket 75, 66, 72, 70, 63, 81. Here you have rows. These are rows and these are columns. Or this one also you can write it as 75, 72, 63, 66, 70, 81. These are rows and these are columns. Look at this one. These are rows. And these are columns. Here also rows and columns. This one, rows represent students and columns represent subjects. I write it here. Rows, what you have? Students. Here what you have in columns? Subjects. Here what you have in rows? Subjects, and columns what you have? Students. I write it here in rows. You have subjects and columns you have students. Okay. These are the two ways that you can represent this table as matrices. What is meant by a matrix? An array of numbers organized in rows and columns is called as a matrix. For example, I can write 3, 2, 1, 1, 2, 1. One matrix. Other one, 3, 2, 1. Here only you have one row. And here, this is column matrix. Only one column here. And this one, -2, 3, 0, x. This is also matrix. Now, look at this matrix. Normally, we name matrix with a capital letter. And here you have matrix A equal 5, 4, 3 minus 2, 1, 0, x, 1, 2a. Here you have algebraic expressions also and negative numbers, zeros. We name matrices with the capital letters. Capital letters. And these are called, what you have inside here, these are called elements. There may be numbers, negative numbers, zeros, simples, algebraic expressions. Example 1. Look at, you have matrix A equal 5, 4, 3, 2, 1, 2, 1, 1, 2. And matrix B 3, 0, 5. Matrix P equal 2, you have C, A, B. Matrix P equal 2, C, A, B. Those matrices are named with capital letters. Example 2. In a Cartesian plane, the coordinates of the points A and B are 0, 5 and 4, 3 respectively. Represent this information in a matrix. Name it P. You have table here. In a table, you have X, Y and A is 0, 5 and B is 4, 3. You have to write it as matrix form. How do we write it? So, P equal 0, 4, 5, 3. Order of a matrix. So first we have a matrix A equal 3, 1, 4, 2, 2, 0. Here number of rows equal to 2. Number of columns equal to 3. So we can write this order as 2 by 3. Let's write it. Here we have number of rows. Number of rows equal to number of columns equal to 3. So we can write this matrix 3, 1, 4, 2, 2, 0. This is our A. That is equal 2 by 3. This is the order. This is the order. We write rows first. Call it 2 by 3. Example 1. Write the order of each of the matrices given below. 1. We have to write number of rows equal, how many rows there? 3. Number of columns 2. Then order equal 3 by 2. This is 3 by 2. Order is 3 by 2 there. Next one. Number of rows. Number of rows 1. Number of columns here 3. Then order equal 1 by 3. This is 1 by 3. Next one. Number of rows. You have 2. Number of columns. You have 1. Then order equal 2 by 1. Always rows first. This is 2 by 1. Next one. Here you have number of rows 2. Number of columns, how many? That is also 2. Then order that is 2 by 2. 2 by 2. Always rows first. Row matrices, column matrices and square matrices. Matrices with only one row are called as row matrices. Let's see some examples. I can write 3, 2, 1. So this is a row matrix. Order is here 1 by 3. I can name this matrix as A. One more, B equal A, B. You have letters inside. So this is also rows 1, 2 columns, 1 by 2 order is. Next, matrices with only one column are called as column matrices. Let's see some examples. I can write 2, 4. I can name this as C equal 2, 4. Here we have 2 rows, 1 column, 2 by 1. Order is 2 by 1 there. And D equal 5, 2, 1. So how many rows? 3 and columns 1, 3 by 1. Next, matrices which have equal number of rows and columns are called as square matrices. Equal number of rows and columns. See some examples. Example, I can write matrix E is equal A, B, C, D. What's order here? 2 by 2. Rows, you have 2 rows and 2 columns there. Rows and columns are equal. So it's a square matrix. And let's see one more example. F equal 5, 2, 1, 3, 1, 3, 0, 4, 0. How many rows? 3. And columns also 3. So it's a square matrix. If the rows and columns are equal, these are called square matrices. Identity matrices and symmetric matrices. Suppose you have a matrix P equal 3, 2, 4, 6, 5, 1, 2, 1, 0. If you draw a line here to here, from top leftmost corner to bottom rightmost corner, we call it as a main diagonal. This is we call this one called main diagonal. Main diagonal. So what's the order here? 3 by 3. It's a square matrix. Let's see one more example. Suppose if we have matrix Q equal 2, 4, 1, 3. So this is 2 by 2 square matrix. If you draw a main diagonal, we call this is main diagonal. This is main diagonal here. So you should have some idea about the main diagonal before you study identity matrix and symmetric matrix. Then, what is an identity matrix? If the main diagonal consists of 1 and all the other elements are zeros, the matrix is called identity matrix. Look at these examples. You have A 1 0 0 0 1 0 0 0 1. So this is the main diagonal here. You have only ones there, others are 0. And look at this is an identity matrix. And look at matrix B here, B equal 1 0 0 1. This is 2 by 2. It's also a square matrix. So this is the main diagonal. That is all you have ones there and others 0. So this is also a identity matrix. We can write these identity matrices like this. So our notation is I. Identity matrix we name as I. Using this we can write I 3 by 3 is equal 1 0 0 0 1 0 0 0 1. Here no need to write the order there. And we can write I 2 by 2 is equal 1 0 0 1. What are symmetric matrices? If the elements around the main diagonal of a square matrix are equal to each other and placed symmetrically about the main diagonal are called symmetric matrices. Look at this matrix X equal 3, 2, 1, 2, 0, 4, 1, 4, 5. So this is the main diagonal. So you have 2 there and 2 there, and 1 here and 1, and 4 here and 4. So they are placed symmetrically about the main diagonal. So this main diagonal is acting like a mirror line. So these are called symmetric matrices. Here y, this is y is equal 1, 5, 5, 3 here. This is 2 by 2 order square matrix. So if you draw a main diagonal here, you have 5 here and 5 here. So this is a symmetric matrix. And look at this one. This is the main diagonal. This is also 2 by 2. And you have zeros. Main diagonal is acting like a mirror line. This is also a symmetric matrix. All identity matrices and symmetric matrices are square matrices. Okay kids, now you can try exercise 19.1. 19.2 Addition and subtraction of matrices. Addition of matrices are defined only for matrices of same order. If x equal x1, x2, x3, x4 and y equal y1, y2, y3, y4, then x plus y equal x1 plus y1, x2 plus y2, x3 plus y3, x4 plus y4. You add corresponding terms x1, y1, x2, y2, x3, y3, x4, y4. Here orders are same. This is also 2 by 2 and 2 by 2. Let's see one example here. You have A 41 41 20 95. You have B 1639 28. Let's see the order here. We have 3 rows, 2 columns. 3 by 2. Order is 3 by 2. And this is also 3 by 2. Same order, so we can add these two matrices. Add these two, A plus B is equal, you have to add corresponding terms here, 4 plus 1, 1 plus 6, 2 plus 3, 0 plus 9, 9 plus 2, 5 plus 8. What's the answer? Let's see. We have 5, we have 7, again 5, 9, 11 and 13. So order here, that is also 3 by 2. Example 1. Praveen and Tarindu are two bowlers in the school cricket team. The number of wickets they took in the year 2014 and 2015 in 1 day and 2 day matches are shown in the table given below. Here you have wickets taken in 1 day matches. This table represents that one. And the wickets taken in 2 day matches you have here. So let's take information on 1 day matches as matrix A and 2 day matches as matrix B. So we take this one as matrix A and this one as matrix B. So you can write in matrix form A equal 21, 23, 15 and 16. And B equal 14, 16, 9, 19. So let's consider A plus B here. What is A plus B here? You have to add 21 plus 14, that is 35. 23 add 16, 39. 15 add 9, 24. And 16 add 19, that is 35. All A and B are 2 by 2 matrix, and A plus B also 2 by 2. What does A plus B represent? It represents total number of wickets Praveen and Tarindu took in 2014 and 2015, both one-day and two-day matches. Subtraction of matrices. Subtraction of matrices is defined only for matrices of same order. Have a look. You have matrix A equal 5, 9, 2, 3 and matrix B equal 1, 4, 6, 0. They have matrix A is, what's the order here? 2 by 2 and here also 2 by 2. So we can subtract A minus B, that is equal. You have to subtract corresponding elements here. So 5 minus 1. 5 minus 1. 9 minus 4. 2 minus 6. 3 minus 0. So what's the answer? You have 4, 5, minus 4 and 3. This is also 2 by 2. See this one. You have 2 by 2, 2 by 2, and this is also 2 by 2. You have x here. The example x 2, 2, 2, 2, 2, 2, 2, 2, 2. All are 2's there. And y equal 1, 0, 0, 0, 1, 0, 0, 0, 1. This is identity matrix. X minus y. What is that? This is also 3 by 3 and this is also 3 by 3. They are in same order. We can subtract. Then 2 minus 1. You have to subtract corresponding elements there. 2 minus 0. 2 minus 0 here. 2 minus 0. 2 minus 1. 2 minus 0. 2 minus 0. 2 minus 0. 2 minus 1 there. So what's the answer? 1, 2, 2. 2, 1, 2. 2, 2, 1. This is also 3 by 3. Equality of two matrices. If two matrices are equal, their order and the corresponding elements should be equal. You have matrix A here, 2, 3, 10, 9, and B you have A, B, C, D. So order of A is 2 by 2 and B is 2 by 2. Order is equal here. Here also 2 by 2 and 2 by 2. Order equal. If A equal B, A should be equal to 2 and B should be equal to 3 and C should be equal to 10 and D should be equal to 9. Order and the corresponding element should be equal. Therefore, A equal B. If two matrices are equal, order and the corresponding element should be equal. Okay, kids, now you can try exercise 19.2. 19.3, multiplication of a matrix by a number. You have matrix A here, A equal 3, 1, 0, minus 2, 8, 1. If you ask to multiply A 5, you can write 5A is equal 5 times A. 3, 1, 0, minus 2, 8, 1. What you have to do here, you have to multiply all elements inside by 5. What you have to do, 5 into 3, 5 into 1, 5 into 0, 5 into minus 2, 5 into 8, 5 into 1. That is equal, you have 5 here, 15. So 15, 5, 0, minus 10, 40, and 5. Let's see, minus 3a. So what you have to do? You have to multiply this inside 1 by minus 3. You have to multiply all the elements by minus 3. 3, 1, 0, minus 2, 8, 1. That is equal, minus 3 into 3, it's minus 9, minus 3 into 1, minus 3, minus 3 into 0, 0, minus 3 into minus 2, plus 6, minus 3 into 8, minus 24, and minus 3. So that is minus 3a, minus 9, minus 3, 0, 6, minus 24, and minus 3. Look at another example here. If x equal 2, 4, 1, 0 and y equal 5 minus 2, 2, 1, then find the matrix 3x minus 2y. You have to find 3x minus 2y. 3 times x. 3 times x. What you have? 2, 4, 1, 0. Minus 2 times y. 5 minus 2, 2, 1. We'll do at once. 3 times 2, 6. 3 times 4, 12. 3 times 1, 2. 3 times 0, 0. You have to multiply all the elements inside here. Then you put minus sign there. 2 into 5, it's 10. 2 into minus 2, minus 4. 2 into 2, 4. 2 into 1, 2. Now you have to subtract there. 6 minus 10, that is minus 4. 12 minus minus 4, it becomes plus. 12 plus 4, that is 16. 3 minus 4 minus 1, 0 minus 2 minus 2. So this is your answer. Minus 4, 16, minus 1, minus 2. This is your 3x minus 2y. This is your answer. That is equal minus 4, 16, minus 1, minus 2. Okay, kids, now you can try exercise 19.3. 19.4 Multiplication of matrices. You can multiply matrices only if the number of columns of the first matrix is equal to the number of rows of the second matrix. Have a look. If you have order of matrix A is m by n and the order of matrix B is n by p, the order of the resultant matrix will be m by p. Let's write that one. Order of A is equal m by n. We have to multiply this one with B. Order is n by p. So the number of columns in the first matrix equal number of rows in the second matrix. Here, number of columns of the first matrix is equal to the number of rows of the second matrix. Then we can write the resultant one, the order of the resultant one, that is m by p. These two equal. This is the AB, the order of the resultant matrix equal to m by p. Let us assume that A equal A1, A2 and B equal B1, B2. Accordingly, the order of A is equal to 1 by 2 and order of B is 2 by 1. So we can define AB. So AB is A1, B1 plus A2, B2. Order of the resultant one, that is 1 by 1. This is 1 by 2 and this is 2 by 1. Here columns equal to rows. So we can define AB. So that is equal A1B1 plus A2B2. The order of the resultant matrix will be 1 by 1. Example 1. Find AB if A equal 5, 2 and B equal 3, 1. First we will check the order here. This is 1 by 2 and this is 2 by 1. Number of columns of the first matrix is equal to the number of rows of the second matrix. These two are equal. We can define AB. AB is equal 5, 2 into 3, 1. So 5, this row, this column, you have to multiply. 5 times 3 plus 2 times 1. So what is the order of the resultant one? That is 1 by 1. So 15 plus 2, that is 17. 1 by 1. This is our answer. Example 2. If x equal 4, 6, 2, 3 and y equal 1, 7, then show that xy is defined and find it. Is yx defined? Show that xy is defined. We have to write x 4, 6, 2, 3 and y equal 1, 7. What is the order here? X, that is 2 by 2, that is 2 by, y is 2 by 1. Then here columns equal to rows. So we can define. Therefore, number of columns of x equal to number of rows of y. Therefore, we can define xy. How to find xy now? Xy is equal 4, 6, 2, 3 and 1, 7. So how do you multiply that one? 4 times 1 plus 6 times 7 and 2 times 1 plus 3 times 7. So what's the order of the resultant matrix? XY should be 2 by 1. You have 4 plus 42, that is 46. And 2 plus 21, that is 23. 2 by 1. This is XY. Let's see now. YX can be defined YX. You have Y. What's the order here? 2 by 1. And X you have, that is 2 by 2. Number of columns of the first matrix, number of rows of the second matrix. Are they equal? No, they are not equal. So therefore, yx cannot define. Yx cannot define. Next example, let P equal 2 minus 1 and Q equal 6, 3. Define PQ and QP. Let's see, P that is equal 2 minus 1, Q that is equal 6, 3. So first we have to check the orders there. So what's the order? P, that is 2 by 1. And this one 1 by 2. Here columns equal to rows. These two equal. Then we can define PQ. PQ equal 2 minus 1, 6, 3. You have to multiply this row, this column, this row, this column, and this row, this column, and this row, this column. Order of the resultant matrix will be 2 by 2. Let's see. 2 into 6 and 2 into 3. And minus 1 into 6 minus 1 into 3. So you have 12, 6, minus 6 and minus 3. This is PQ. Order here 2 by 2. Now let's see, we can define QP. We write Q here. Q is 6, 3 and P 2 minus 1. So QP equals 6, 3. Let's check the order first. The order here 1 by 2 and here 2 by 1. So columns equal to rows here. We can define QP. Now 6, 3, 2 minus 1. What's the order of the resultant matrix here? That is 1 by 1. You have to multiply this row with this column. 6 into 2 plus 3 into minus 1. 12 plus minus 3 is equal to 9. This is the resultant matrix. Order of the resultant matrix is equal to 1 by 1. Here, both PQ and QP can be defined. But are they equal? No. PQ is not equal to QP. Example 3, you have C 3214 and you have D 4325. Find CD and find DC. First, you have to find CD. CD 3214 4325. So let's check the order here. This is 2 by 2 and this is also 2 by 2. Here columns, this is equal to this one. So we can define CD. Let's see. Here you have to multiply this row with this column, this row with this column, and this row with this column, and this row with this column. Your order of resultant matrix will be 2 by 2 here. Let's see. 3 into 4 plus 2 into 2. 3 into 3 plus 2 into 5. 1 into 4 plus 4 into 2. 1 into 3 plus 4 into 5 equal. You have 3 into 4, 12. 12 plus 4 is 16. You have 3 into 3, 9 plus 10, 19. 4 plus 8, it's 12. And 3 plus 9, 3 plus 20, 23. So 2 by 2. This is CD. Let's find DC. DC. 4325. You have 3214. That is C. So this is also 2 by 2 and 2 by 2. So Here columns equal rows. We can define DC. Here you have to multiply this row, this column, this row, this column, and this row, this column, this row, this column. What's the order of the resultant matrix? That is 2 by 2. 4 into 3 plus 3 into 1. 4 into 2 plus 3 into 4. 2 into 3 plus 5 into 1. 2 into 2 plus 5 into 4. So 4 into 3 is 12 plus 3 is 15. 8 plus 12 is 20. 6 plus 5 is 11. And you have 24 here. So 2 by 2 is the order there. Then we can define both CD and DC, but they are not equal. CD is not equal to DC. Okay kids, now you can try exercise 19.4. Thank you for watching.